You are cruising down the highway, making great time, and then a sea of red brake lights. You are stuck. For decades, driving was essentially a guessing game. You could not know what was happening 2 miles ahead of you until you were already trapped in it. Before smartphones, finding our way meant relying on static information, folding out large paper maps, hoping the printed routes were still accurate. Even early digital navigation systems had a major blind spot. They could pinpoint your exact location on a screen, but they had no visibility into a multi-car pileup just around the next bend. Without the ability to see into the future of their route, human drivers were forced to be entirely reactive. You could only respond to the obstacles that were directly inside your own line of sight. That problem shifted when data science entered the dashboard. The navigation apps on our phones today act as intelligent personal co-pilots. This mapping model shows how these apps constantly pull in massive streams of live GPS coordinates, weather updates, and speed reports. If an accident occurs ahead, the algorithm calculates the delay and immediately reroutes you to an open street. This intelligence extends under the hood through predictive maintenance. AI analyzes data from internal sensors to anticipate engine issues before they cause a breakdown. But optimizing one car creates a new mathematical problem. If an algorithm directs 10,000 drivers to the same side street, you haven't solved traffic, you've just relocated it. Fixing a single commute can be done on a smartphone. Preventing systemic city gridlock requires an entirely invisible layer of intelligent infrastructure. To keep millions of people moving, AI steps outside the individual vehicle to manage the physical environment itself. Cities are deploying computer vision, a technology that allows machines to identify and interpret visual information. By feeding intersection cameras into the system, the AI can see the exact volume of cars on the road in real time. Traditionally, traffic lights operate on fixed, unyielding timers. A light stays green for 30 seconds, whether there are 50 cars waiting or none at all. This split-screen comparison shows the alternative. With visual data feeding the system, those lights become dynamic. The AI can hold a light green longer to clear out a sudden wave of congestion, preventing drivers from having to hit the brakes. By constantly reading the visual rhythm of the streets, the grid stops being a rigid obstacle course and behaves as an adaptable, living system. Put this technology under extreme stress, and its value becomes obvious. During the annual monsoon season in Mumbai, heavy rains routinely trigger severe citywide traffic gridlock. To combat this, an AI traffic system was built to analyze decades of historical weather data right alongside live traffic patterns. This risk map illustrates how the system works. It calculates which low-lying roads will fail first. The AI then adjusts intersection lights and redirects navigation apps to elevated routes well before the storm reaches its peak. The true power of this technology lies in mathematical prediction. Instead of reacting to the water on the road, it anticipates the bottleneck and removes the cars before it happens. This intelligence stretches to the massive scale of public transit to handle the overwhelming volume of daily commuters. To maintain order, machine learning algorithms continuously plot bus routes and track train delays, adjusting schedules on the fly so these massive, complex networks can run on time. Inside the vehicles themselves, safety systems actively monitor for human error. If a driver gets distracted and glances away from the road, the car can issue an alert or even begin to slow down. Artificial intelligence in transportation has evolved beyond a feature for personal cars. It serves as the essential computational glue that keeps modern urban mobility functioning. Putting a map on a screen was only the first step in digitizing how we travel. This visualization demonstrates how AI has built an invisible, predictive infrastructure. It takes millions of isolated drivers, scattered traffic lights, and complex weather forecasts and wires them together into one highly coordinated network. The road is no longer a static surface we simply react to. It has become an active participant in our movement that recalibrates to our presence. The greatest shift AI offers isn't geographic, but a transition from individual, chaotic reaction to a system built on coordinated foresight.